Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Bismillah ar-Rahman ar-Rahim, ladies and gentlemen. Let's continue our CFD tutorials. In this video, we're gonna talk about a very interesting application. We're gonna talk about the operating room or the surgical room simulations. We're gonna use SolidWorks flow simulation, not ANSYS this time. Why? Because it is more easier and ANSYS does not do or carry out the all kind of simulations. We have many software programs that can be used. So let's start. We'll find here some paper, research papers, simulation-based feasibility study of improved air conditioning systems for hospital operating room. You can get this paper to know what's going on. You have here the CFD model and the staff inside the room, and you can put the persons. And here, of course, we care much about the heat gain and the temperature and the dimensions. Okay, and then the grid dependency and the results, of course. And then, of course, here effective ventilation strategies on infection control inside operating theaters. You can find also these kind of things, and you can carry out simulations to study lots of parameters and get the comfort parameters, okay, and to check the height or the orientation of the grellas, the return air grellas, and the supply, okay, and so on. Of course, you do not use, you should, you must get research papers, most recent research papers, and here an experimental exactly like this. I'm gonna let you check out these kind of things by yourself, but now is we're gonna use the SolidWorks Flow Simulation 2012 here. Okay, I'm using it 2016. So examples for HVAC module. When I use HVAC module for the hospital room, okay, it's D1 or D2. You can get this tutorial, the geometry, and this tutorial demonstrates the capability of flow simulation to predict the performance of a building ventilation system and to estimate air quality and general thermal sensation by calculating comfort criteria. This is our target. It's shown how to define projects, specify the heat sources, boundary conditions, and calculation goals, and how to obtain values of comfort criteria. Okay, so you can see the details here. This is not an operation room or not a surgical room, it is for a hospital room. Okay, for the project I supervised last year with the graduation students at Shams University, we used actually an operation room or operating room. So I'm gonna show you, I guess, if I have the model, or we're gonna see this right now. So ceiling lights and forced inlet fresh air, and here the other staff, and here is a visitor, and hospital equipment and patient and TV set for the, and here are the lights, okay, and here forced air removal. So of course you can get this from, here is solid flow simulation program files, this, and you'll find this. You can get all kind of things, and here is the example and the hospital room. Okay, so but we're not gonna use the actual room of this. We're gonna here use a specific design I carried out using Autodesk Inventor. Just here two linings, and here is the inlet and the outlet as you want. Okay, and I guess there is a problem here, but no problem. You can file export SCAD format. Okay, just make it xt step. Okay, come here, find open. Was the room? Okay, does not work, not because the version. Just make it step if you find the problem. Open. Okay, so here we go. Yes, no faulty, no, but to be able to continue save as SOLIDWORKS part. Yes, now I can put any kind of thing in the, I can make it suppress, or I can make it any, I can use anything here. But so I'm gonna file new assembly. Why? Because I'm gonna fill that room. Okay, here is the hospital room. Thanks, and just open here. So just pick out what you want. Here is the patient, neck, arm. No, I do not need the room, arm. Any kind of thing. So as you can see, here is the patient. Okay, just wanted to let you see every part. Now we're gonna close them again. No need for all these things. I'll cancel this. So this proves that here, okay, this I don't wanna now. I only need this. In window assembly, just open the patient. Where is the patient? This is assembly. Only I wanted the assembly. Okay, the patient. Okay, go to assembly. Yes, and here I wanna sort components. Patient. That's why I converted this to SOLIDWORKS. Is it the patient? Okay, I'm gonna open the bed. So the part, yeah, window assembly, insert the bed. Okay, put the bed here. Danka. Okay, this guy, yeah. This is height component. Yeah. Now you are free to do what you want. Okay, this patient you can insert or tools, I'm not sure, component, yeah, rotate 90 by delta z, yes, and x, no, negative 90. Okay, oh, I'm sorry. Okay, yes, can make it one more time. Just I want to rotate it z, positive z. Yeah, this is what I want, and just rotate it also. No. Okay, and here is, yeah, you can put it like this. So I'm just showing you how to play with this components, with these components, just tools, components, and do what you want. You put it like this, or you put it like this. Now I'm gonna make it 90. Okay, yes, and negative 90. Yeah, exactly. So I'm just showing you the method, and you can do it as you want. Move this guy to here, to this point. Come, man. You can use the constraints, but I'm just showing you the method. If you want accurate work, use the constraints. Okay. Of course. That's it. You're done. So now we have here this guy. Okay, that's very good. Okay, where is the hospital room? Just please show component. So if this is the room, move them. Mhm. So let's see here in 3D view. We can use it like this. Okay. Transparency, yeah. That's very good. Now it's the time for the. Notice that I created the room exactly like this, using the cavities, and here if I may suppress that. I can use view my frame. You can create everything here using cavity and extrusion, extrude cut, and here is extrude material. This extrude also material, just to let things work. Okay, now here I can insert another component, is the patient. Yes, like this. Can I'm gonna rotate it. Why look like that. Okay, it will not be a problem. Okay, here we go. This is a hospital room, not a surgical room. Very simple. It's wow. So, gentlemen, we have here is the unit systems, and here is the following parameters are used to estimate the ventilation system effectiveness with respect to contaminant removal effectiveness, and local air quality index. The following parameters are used to estimate the ventilation system effectiveness with respect to the thermal satisfaction of people: air diffusion performance index, predicted mean vote, and predicted percent dissatisfied. Okay, so here we go. Now we have finished that full simulation. Create new wizard. Of course, we have to save the document. So rebuild, can rebuild it or no rebuild. So wizard. Here you can put the project name. So you can put the name here and use any kind of thing. Now the SI units, and you can pick anything from here, pick out. Here is internal. We're gonna use internal. Why? Because I want to investigate the flow inside the room, and exclude cavities without flow conditions. I guess it is for the cavity for example, this, we do not have to carry out the cavity like ANSYS. If you use ANSYS, we have to carry out a cavity for all the kind of stuff inside the room. Why? Because we need to create the mesh for the flow around them. But here is the simplicity for the SolidWorks. It does it by itself, okay? So no need. So here is very good to consider the gravity. Notice negative y if you use another coordinates or another orientation. Please be careful to put select the suitable component direction. Okay, as you know, we have here to investigate the gravity. If we use the vertical axis wind turbine simulations or other simulations that does not require the gravity, or the gravity has very little effect, so we put it 0. So now next, and here are the gases. We're gonna use air, and also there is an expired air in the user defined expired air. Yes, add it. Why? Because there is the air of the room, or the fresh air, and the air comes out from the mouth of the patient. Okay, so you can click new and add it if you do not have it, like this. Okay, so we have here humidity, and of course we have only laminar flow, because hospital and surgical rooms only laminar flow, no turbulence flow inside these kind of rooms will be a disaster, and the infection happens quickly. And here the diabetic wall, and if you wanna do anything, you can make it. So here's roughness. Next, and you can put any kind of thing here, information. Of course, in the mass fraction. Okay, back. Back. I guess we missed something. Over here in the concentration, mass fraction, and 0, and humidity. Do what you want. Okay. So simply, without any errors. Okay, so now it's perfect. So here is the computational domain. You can increase it as you want from this, or you can edit the definition and put values. Okay, so simple to deal with SolidWorks fluid subdomains. We don't need this. Now it's time to boundary conditions. We have here inlet, where let's put this here, and don't want to see the SolidWorks now. Okay, the inventor now. Okay, so inlet flow can apply it, use it, and put 4.8. Yeah, this inlet mass flow or volume flow. It's volume flow 4.8. Inlet volume flow 0.8. Okay, click yes. Okay, I'll add the computational domain. So what we're gonna do is click and select other. Select other. I guess there is a problem here. Yes. Okay, I'm gonna cancel this. So let's see how we can fix it. I need this, or I need the other Let's see how to solve the trick. Okay. 4.8. Let's see if it's gonna work. No. Okay. Okay, gentlemen, let's see how to fix. Okay, let's change the transparency. Go here. Okay, we can make a cut here. So this is the sketch. If I make something like this, okay, or yes, and then go to extrude. And here, see. And this is a solid. Put the sketch here. Mm-hmm. Extrude cut. Roast. Very cut. Okay. 1 millimeter. Okay. Okay, something like this. Gonna make this opening. Okay, I'm gonna come here. Yes, I wanna see the update. So this is the update. Okay, yes. So, gentlemen, after carrying out the extrusion, now it's gonna a very important step is to create a lid. Okay, I'm gonna come here to the face. Okay, I'm gonna use it. Yes, just you click on this. And that's it. Yes, also detected. Yeah. Okay. So now, inlet boundary conditions. By the way, we're gonna use inlet volume flow rate, outlet, and environmental pressure. No problem with this. So 4.8 is volume, and let so here is the lid. Notice that now this only the face, not the whole face. Okay, select the other, and now this is what I want to see. That face inside the domain. Congratulations, we did it. So notice that the arrows only from this face. So this is the beauty of the lid. Now we have here the outlet. So the outlet, as you can see, we have to go to hospital room and do this amazing thing. Also, you must be more accurate than me. And here we go again. It's very interesting when you know how to solve the problems by yourself. Thanks. Extrude cut. I'm gonna make it 0.1 millimeter. That's it. So yes, I wanna see the update. It will tell me that this may change the dimensions of the inlet or outlet area, and this of course will affect the velocity. So I'm telling you, consider it from the beginning. You make it make it greater, and then you select the extrude or the dimensions while you carry out the extrusion. Use the real dimensions of the area you want. Okay, so I'm gonna tell you, okay, you can do this without any problem. Third, now burn the condition. No, as you know, we're gonna make it another lid. Now select the cross section. This, yeah, face. Vielen Dank. So boundary conditions. Now this. Out. Select other. Yes, this is not out of the domain. Yeah, we succeeded, gentlemen. I've just did it, but now I wanna it outlet volume flow. So the outlet volume flow is 2.6. Really, really, this is amazing from this area. Okay, so as you can see, this, I guess, SOLIDWORKS consider it from here to here, so no problem with the dimensions, by the way. I'm just I wanted to make sure of it, so I guess no problem of what we have done. So now we have inlet, we have outlet. This is amazing. Now we have the environmental pressure according to the tutorial. So now we're gonna make another extrusion. Yeah. Visit the hospital room. Where are you? Here we go again. So, by the way, I guess it is good. There is already an extrusion, so let's try it. Create a lid. No, no cross sections here. So why here? Okay, let's do it. No problem. We're not gonna lose anything. So come here. Just make something like this. Yeah, extrude cut. 0.1. Okay, go assembly. Of course, yes, change it. Yeah. Just wanna see something. Okay, just make sure that you select it. You may not need to break the extrusion. So now is the sort boundary conditions. I wanna this to be environmental. Okay, here the same the same message. Now I wanna this. Awesome. Danka. Here is environmental pressure. Okay, so we have succeeded. By the way, if you go here and see this, you will must find the lids. Lid 2, 3, 4. It's 1, 2, 3 for the lids. This is pretty important, and not all people know this trick. That's why they never run this simulation. Never. If you know, if you do not know this kind of tricks. So, gentlemen, now we have here the inlet volume flow for a patient for the patient, or the face of the patient component representing patient's mouth as shown here. Volume flow rate normal to phase substance mass fraction. So we have here type inlet volume flow rate or inlet flow. Again, you can consider this with you. Expired air can make it extrude, or you come here again. Okay, let's see if we can make it here. Inlet or outlet. Okay, so for expired air volume flow rate normal is 12 liter per minute. Okay, so this is the mass fraction. Inlet mass flow rate 12 volume. Okay, it's liter per minute, 12 cubic meter per second, 12 liter per minute. This course is so small. Okay. So contaminated expired air, that's expired, yeah, parameters, volume flow rate, substance concentrations. And here is the other thing that we have to do is substance concentrations. Okay, here is 0 and 1. This is very important, by the way, so you can click yes. If you find here, open this again, you find this is air 1, okay? That's it. So this is the fresh air, but here is not fresh air. Okay, consider this if you want. So now we have to specify the heat. Okay, flow emission insert surface source, and here is this is applied to surface sources, and where is flow simulation? Sorry. So as you can see here, on goals, check geometry, and yeah. Okay, gentlemen, here is for the specifying heat sources. I'm sorry, I do not know what's going on here. I should or I must see a surface or insert surface source, but I do not see it right now. I do not know what's the problem. We did not find or did not face a problem before, so I'm sorry. I'm not gonna show you this because I cannot do it, but you have to find it, and you will only just select the faces that like this parameter, specify heat transfer rate, 81 watts, and so on. It's pretty simple. And also you will select the lighting surfaces and put it here. You will find here the surface sources or the heat sources if everything is okay, TV sources, and so on. And then specify calculation control options. After that, control options, this is here is what you want is LML, the average time for fluid to travel from the selected inlet opening to the point considering both the velocity and diffusion and so on. You will follow these kind of things, and you're the advanced goals criteria and refinement and solving. Yes, calculate LMA, calculate comfort parameters. This is one of the greatest things here, the most important things. Of course, air condition control parameters or comfort parameters, or also for the goals, the average sort of global goals. You can point goals, put everything. Mean radiant temperature, operative temperature, and velocity. So the average temperature, yes, mean radiant temperature, velocity, operative temperature, mean radiant temperature, radiation, operative temperature, and yes, average, and the velocity. And you get everything. Average volume fraction of expired air, average volume fraction expired air, average. Okay, these are the global goals that we need to get the contours of them. Also, you can put goals, point goals, surface goals, everything you need here. and you can make also write an equation goal. For example, if you create a simulation, a flow over a cylinder or a valve or these kind of things, you can write the equation here of the drag force, and there is a tutorial about this. Actually, you can use it. Can get select one of these and put it in the equation. It's available on YouTube, so no problem. So now is the mesh. You can get here the global mesh. 1, 2, 3 as you want. Of course, you can carry out a mesh dependency study. Increasing this will increase the mesh cells. Okay, yes. So now we have the mesh. This is one of the great things here, that easily you can create the mesh. Also, you can insert local mesh. Why? Because if you want to make a refinement at specific area, specific faces, around specific faces, you can select them and make the refinement as you want, no problem at all. Okay, after that you can run the simulation. I'm sorry again, I did not find the surfaces that are supposed to be a generation. I'm sorry, but you have to make it. So no calculation. I have 4 CPU threads. Automatically will find it. Where performance 4 is the maximum. Of course, it will be Perl. You okay? This computer, of course, you can on computers, and then you can run it. So here we go. No warnings. Also can check geometry by checking the geometry from the icon of checking geometry. Okay, so let's see. So preparing model. ANSYS will take too much time for preparing these kind of models, and too much time for creating mesh, too much time for running it. So it's not suitable for these complex geometries. It's only for other simulations. Prepare model, and here is mesh refining, mesh capturing. Of course, you need to add every medical equipment as a part, separate part, to be able to use to select it. Okay, I'm just showing you a very simple model. You can carry out the use the room and insert the staff inside it. Insert it. So mesh capturing, okay. So as you can see here, there is a surface source for the humans. You can read this by yourself, and you can add it. Version started, normally finished. Okay. And now we're initializing. We have here all what you want. Yes. Be careful when you deal with units. Very fair calculation. So calculation and variations. So iteration 1. And here are the iterations. Also, you can sort gold plot. Here are the values. Yes, to see the simulations or results. Of course, it will take some time, and when it finish, you will find it, and you can pause it and stop it. Okay, so you may stop it. No, I don't want to save anything now. We're gonna open my old model to show you something, because we cannot run it right now. It will take some time. Okay. Okay, here is for the results. Now you have the mesh only. Of course, you can click on summary. You'll find all what you want from here for the mesh and everything. Okay, you can save as txt file. Okay, now I'm gonna open my old simulation. Yes, so this is the heat sources that I talked about. So you can insert surface source, and you can select anything you need and put the wattage inside it. Okay, look, put it what? That's it. It's very simple. Why? Because I found that icon that day. I don't know what happened. Okay, anyway, no problem. This is the only missing thing. I run the simulation so we can load it. Every time you open it, you must load it like this. And here, of course, I'm gonna delete this, no problem now. Yeah, and here is the cut plot. Delete it. I'm gonna show you. So here is the cut plot. Insert the cut plot. You still SOLIDWORKS temperature or whatever you want. Notice that here are the comfort parameters that we talked about. And of course you can, so please study these things. These are the most important thing you should know. And cold and cool, slightly cool and natural, and that's it. You will find all what you want in this PDF. So no need now to cover it, because I wanna make it short for you. Just want and you can export to Excel all kind of things. Okay, where here the contour, and you put this, you can change it. Okay, you can this is the cut plot, and it will be temperature. and you can, as you can see, of course, because it was a very random model, and I'm just showing you. You will find, if you make everything right, you will find the contours like this. Okay, so here you can edit definition, of course, the velocity, and so on. And here is cut plots. I'll search LAQI. You'll find it, of course. Why? Because we used the comfort parameters option. All these kind of things, you will find it here. Okay, so that's it. I will let you continue by yourself. Okay, so thank you very much. I'm really sorry about the surface. If I know that, I will try to recover it. Okay, so but please, you have to make it again. Okay, thank you very much. And here is the velocity. You can change it, of course, and also you can, I guess, you can change the scale. I'm not, yeah, edit. Edit, you can put maximum and minimum scale, and then 10 or up to what you want. Okay. Okay, gentlemen, ladies and gentlemen, thank you very much. I'm sorry it was for a long tutorial, but you have to cover all these kind of things, and I wish you get something today, and be safe. So this is SolidWorks. No need to create the cavity like the ANSYS tutorials or Boolean, this kind of stuff. No, you only do what I have shown you. Okay, thank you very much, and thank you all the people who I worked with the last year for this surgical simulation. They used surgical simulation, not only not just a room like this. You all did right and correct. Thank you very much. Wassalamu alaikum warahmatullahi wabarakatuh.